Done with the first problem. We're on down here to the box and whisker problem, number 2. Okay. So it gives us the box and whisker. We can see all our different values. If you're a labeler, there you can label them. Min, Q1, median, otherwise known as Q2, and then Q3 and maximum. Those are all our different values. Remember, a box and whisker does not tell us every single individual data point. We only know a handful of them. Okay, a couple in fact. But we can start answering some questions. And what's tricky about these and the histograms is you've got to know which questions you can answer and which questions you can't answer. A is a great example of that. It says, what percent of the students checked out between 6 and 8 books? We can't tell how many exactly, what number of students, but we can tell what percent because we know every piece of a box and whisker plot is worth 25%, no matter how big or how small the piece is. They're all worth 25%. Well, check out between 6 and 8 books. That's between 6 and 8. That's both of my boxes, and that's a grand total of 50% of our data. Similarly for B, what percent check out 6 or less? Well, here's 6. 6 or less is going to be anything down in that lower quadrant, which is 25%. C is our first good example of a question you can't answer, but a lot of people are going to. Okay? It says, what is the mean? Well, in a box and whisker plot, we don't use the mean, and we can't find it. There's nowhere up here, and you'll see where I did all my labeling, nowhere up there did I label anything as the mean because the mean is not one of our 5-number summary, not part of our 5-number summary. Okay? What is the median? Well, the median we can tell. You can see where I labeled it up there. It's 7. Okay? The median is always the dead center of those 2 boxes. It's always labeled up there, 7. E says how many students were in the survey. We can't tell. Box and whisker plots don't tell us that. Notice on a dot plot, you can tell how many students there were because you see every single data point. But a box and whisker does not tell us how many students were in this survey. F is where things get a little bit dicey. It says describe the distribution. Now, I've had people tell me, they're like, well, 50% of our data is right here in the middle, and that's completely even, so it's symmetric. I tend to lean towards this being skewed right. The way I think about that is I've got 75% of my data all bundled into that left side. And that's only 4 units of length between 4 and 8. Whereas I've got 25% of my data spread out all the way down here. So to me, it seems like the right side of our data has very few points, or they're very sparse. They're very spread out. When there's few points in a large area, I think that that's probably my skewed area. So I would describe this as skewed to the right. Now, you could argue it either way. You've got to just give us your best shot, and you've got to explain your reasoning. One of your big explanation comes with these next 2 answers. Okay? Depending on what you answer for F, it will change what your answers for G and H should be. Okay? What I mean by that is that every time we have skewed data, our center should be measured with the median. And anytime we're doing that, we should also use IQR for our spread. Okay, so our center needs to be that, our spread needs to be that. Alternatively, if we would have said this data is symmetric, that's okay, you'd have to kind of justify it. But if our data was symmetric, we want to use the mean as our center, and we want to use the MAD as our spread. Okay? So depending on what you say for F, it will change what your answer to G and H should be. I think this data is skewed right. I already wrote that for F. I think the data is skewed to the right. Well, if it's skewed to right, my measure of central tendency needs to be median. My measure of spread needs to be IQR. These 3 things go hand in hand, and these 3 things go hand in hand. Okay? Determine if an outlier exists. If so, calculate it. Outliers are justified by fences. So we have to figure out what our upper and lower fences are. I've kind of got a little bit of a mess up here, so I'm going to erase a lot of what I've got written up here up top. If you need it, just rewind a little bit, but I need to be able to see these numbers a little more clearly, okay? To find my upper and lower fence, I need my Q3 and my Q1. Well, they are 8 and 6, okay? Which means my IQR is something I can calculate now. It's always Q3 minus Q1, which is 8 minus 6, which is just 2. It's a very small IQR. That means the bulk of our data, that middle 50%, is not spread out because IQR is a measure of spread, okay? But we needed that IQR so we could calculate our upper and lower fences. Our lower fence and our upper fence will determine our outliers, and they are calculated just like they were in the last problem, and I'm just going to do them in the calculator. Our lower fence is Q1, which was 6, minus 1.5 times our IQR, which was 2. So our lower fence is 3. Our upper fence is very similar. It's 8, which is our Q3, plus 1.5 times our IQR. So again, we used Q1 and minus, we used Q3 and plus, but this stayed the same. So our lower fence is 3, our upper fence is 11. Now we're using those and building those fences to look for outliers in our original data. Our lower fence was 3, that'd be roughly right here. Our upper fence was 11. And now we're looking for outliers. We see that according to our lower fence, we have no outliers on our lower side. Our data stopped off right here with a minimum of 4, which is inside our lower fence. Remember, we want stuff to be inside these two fences. However, on our upper side, we see we have our upper fence at 11, but our data from our box and whisker plot extends further out than that, meaning that there are indeed outliers on the top side of our data, on the upper part of our data. Now's where things get tricky, because a lot of people get a little bit overzealous with this part, trying to figure out outliers and tell us stuff like you can't tell how many there are, or I don't know any of them, but I know there are some. There are very specific things we can tell about this outlier. One is that there is definitely an outlier at 14, because that's our maximum. For it to be our maximum, it had to be part of the data set. The next thing is that we can't tell how many are actually in here. We don't know if 14 was the only outlier. Maybe there was also a 13 or a 12 and a half or anything like that. We don't know any of the other outliers. The only thing we know for sure is that there is in fact an outlier at 14. So this is where we like to say that there is at least one outlier. And I always just put at 14. I don't know if there's more than that, but I know there's at least one, and that it is at 14. So maybe a better way to do is put that in two separate things. Put at least one outlier, and then maybe 14 is an outlier. That way you're saying there might be more than one outlier, but I know there's definitely one at 14, okay? Saying at least one outlier at 14 means maybe there's multiple at 14, but they don't all have to be at 14. We just know that there is one at 14. There might be other ones at 11 and a half, 12, 12 and a half, any of those other sort of numbers, okay? We don't know. But we know there is an outlier because there our data extended past our upper fence.